Under the sea, under the sea. Darling, it's better down where it's wetter. Take it from...
Geologists theorize that the Earth was formed by small, cold chunks of rock that surrounded the Sun. The rocks came together one by one to form the Earth, and as the rocks clumped together, collisions between the rocks, along with gravitational compaction and radioactive decay, created heat. Earth's temperature rose until it melted and cooled. Pockets of magma under pressure escaped in the form of volcanoes. Active volcanoes released water vapor and gases, and the Earth was a big sea of lava. Eventually, Earth cooled completely and became solid rock, which allowed clouds of water vapor from the volcanoes to form water, which fell as rain, and it rained, and it rained, and it rained. Studying the seafloor can now be done using a variety of tools and equipment. Rocks can be broken from the seafloor by a rock dredge, which is an open steel container dragged over the ocean bottom at the end of a cable. Sediments can be sampled with a corer, a weighted steel pipe dropped vertically into the mud and sand of the ocean floor. It can also be studied using sonar. Echo sounding measures water depth and draws profiles of submarine topography. A sound sent from a ship bounces off the seafloor and returns to the ship. Multi-beam sonar sends out and records a variety of sound resources and is able to map the seafloor in more detail. Side-scan sonar measures the intensity of sound. Seismic reflection profiler, a tool similar to echo sounding, uses a louder noise at a lower frequency, which penetrates the bottom of the ocean and reflects from layers within the rock. Submersibles, which are basically small submarines, are able to take geologists to the seafloor to get an up-close and personal view of the seafloor, to obtain samples, and to photograph. Some submersibles are able to withstand high pressure in the deepest parts of the sea and are controlled remotely. A continental shelf is a shallow submarine platform at the edge of a continent. It declines at an angle of 0.1 degrees seaward. Their geologic origin is related to plate tectonics. A continental slope is noticeably steeper and extends 100 to 200 meters at the edge of a continental shelf and continues to oceanic depths. The average angle of the slope is 4 to 5 degrees. The continental rise slopes at 0.5 degrees and extends from the lower part of the continental slope to the deep sea floor. It also typically ends in a flat abyssal plain. Abyssal plains are formed of horizontal layers of sediments, usually deposited by turbidity currents. The mid-oceanic ridge is an undersea mountain range that extends around the world. It is made of mostly basalt, is more than 80,000 kilometers long, and 1,500 to 2,500 kilometers wide. It rises 2 to 3 kilometers above the ocean floor. A rift valley, where the crust is undergoing extension, runs down the crest of the ridge. It is 1 to 2 kilometers deep and several kilometers wide. Seamounts are conical undersea mountains that rise 1,000 meters or more above the sea floor. Some rise above sea level to form islands. Rock dredged from seamounts are almost always basalt, so it is believed that they are extinct volcanoes. Guyots are flat-topped seamounts found mostly in the West Pacific Ocean. Submarine canyons are V-shaped valleys that run across continental shelves and down continental slopes. An oceanic trench is a narrow, deep trough parallel to the edge of a continent or an island arc. The Marianas Trench is the deepest part in any ocean of the world, with a depth of 10,924 meters or almost 11 kilometers. It is located in the Pacific Ocean, just east of the Philippines. Associated with trenches are the earthquakes of the Benioff seismic zones, which begin at a trench and dip landward under continents or island arcs. Volcanoes are found above the upper part of the Benioff zones and are usually arranged parallel to trenches. These belts of volcanoes form island arcs. The rock from these volcanoes is usually andesite, which is in between basaltic crust and granitic continental crust. There is still much we do not know about the ocean. Through the advanced technology we have now, we are continuing to learn more and more each day. Geologists work to raise a flag of awareness of how we continue to destroy what is left of the ocean and hope to unlock the secrets of the ocean one sediment at a time.